and welcome to the Global Electronics Friday Talk Show with your host Rajiv Kulkarni from Dallas, Texas. Yes, I say good morning, good afternoon, good evening because I don't know which part of the world you're watching this show from. So I hope everybody is keeping good and getting ready for the Valentine's weekend. Yes, and today we are bringing you a very interesting topic because this is very, very critical in terms of manufacturing, especially electronics manufacturing, I'll say. Global Electronics thanks all the supporters who support our channel and who support our show on a regular basis, and also the supporters who are audience. You watch our show on a weekly basis and support the channel and also subscribe and share the channel link. Thank you very much for that. So Global Electronics main objective is to help the electronics community people to know about the challenges those are faced in the electronics world, and that too especially in the electronics manufacturing, whether it can be process related issues, whether it can be quality issues, whether it can be supply chain, whether it can be pricing point, and so on and so forth. So there are many issues when it comes to manufacturing activities. And so we have been covering different topics every week. It is not the same topic, but there are certain times we go into the session 1, session 2, session 3 if there are vast subject that we try to cover. With that said, let's talk about briefly about today's topic, which is the manufacturing of printed circuit boards for advanced technologies poses challenges, and what can be those challenges? Design and layout challenges, material and process control, manufacturing challenges, or inspection and testing challenges, or supply chain or cost challenges. And how you overcome all these challenges. There are many experts, and there are many key people engaged in sorting this on a day-to-day basis. But definitely it is always a challenge, and we have to face those challenges and keep working towards the betterment, how we improve those challenges and face those challenges. So today's topic, we are inviting a special guest from India, which is from a southern state of India called Hyderabad. That falls in Andhra Pradesh. So a brief few background about this gentleman is he's an accomplished quality and manufacturing professional with over 22 plus years experience in defense, aerospace, and RF and microwave electronics manufacturing. He's a strategic leader with hands-on experience in quality management system, which is also called as QMS, Lean Six Sigma, supplier development, and process optimization. He has played a pivotal role in driving excellence in electronics manufacturing for defense application. He is passionate about building a world-class defense manufacturing capabilities, ensuring zero-defect delivery, which is very impressive, and spearheading initiatives that align with the global quality standards such as AS 9100D, ISO 9001, IPC, NADCAP, and etc. He has led a large cross-functional teams, executed traceabilities, automation projects, and established training programs to elevate workforce competency in defense electronics. Ladies and gentlemen, let's welcome Mr. GS Gurudatta, who works in a company called Astra Microwave Products Private Limited or Limited in Hyderabad, and as a quality leader. Mr. GS Gurudatta, welcome to the show. Good evening to you. How are you this evening?
Very good evening, sir. I'm good. Thank you for your kind words. It is very impressive. And
Thank you.
I'd like to introduce myself. As Mr. Rajiv told, I'm GS Gurudatta. So working in Astra Micro Products Limited for around 13 years. And overall experience is about 22 years in defense and aerospace. manufacturing and other allied services.
Okay, excellent.
Yes. Yeah.
Yeah, go ahead, go ahead.
So I would like to bring the entire PCB manufacturing constraints what we have faced in our new products, especially. So in the we do cater to the B2P projects like build to print. So we receive designs from the customers all over the world, and we run a turnkey uh, projects here in our manufacturing facility. So when we receive the PCBs, Gerbers from different manufacturing for manufacturing services. So we used to face a lot of challenges. So in the
Yeah,
PCB manufacturing, so it is like in every country. So if you give to any country, this manufacturing challenges will be there. So I would like to address those manufacturing challenges today in this session, and with
excellent.
so this is the brief about my
Sure,
topic today.
sure, sir. Thank you very much, Mr. Gurudatta, for giving a brief background about yourself, as well as what you are going to present today, what we are going to talk about today. Because we know everybody thinks that PCB manufacturing is a very easy product or a commodity product, but I personally feel that printed circuit boards is a very cumbersome technology driven manufacturing product, I would say, because it is not an easy product. Because today what you are manufacturing, tomorrow the things can be different. Tomorrow there is again a different challenges might arise from the manufacturing perspective. So with that said, let's start our today's discussion. And I know that there are many challenges that we pose in the
Yes.
PCB, manufacturing the advanced technologies. So for the people who are watching this, when we talk about advanced technologies, we are specially focusing on the defense and aviation and defense sector. Is that correct, Mr. Gurudatta?
Yes, yes. So we
Okay.
are cater specifically for defense and aerospace sector.
Okay, so let's have a presentation that Mr. Gurudatta has shared with us, so we can, walk accordingly. So first of all, I think when we start the manufacturing activities in the printed circuit boards, the design and layout process is a very important factor. What do you think on that?
Yes, definitely. Because whenever the PCB manufacturing we initiated, the process is initiated,
Yeah,
so we have to pose lot of a lot of variations. Like from PCB to manufacture, we have a lot of variations in terms of process, in terms of their capabilities, in terms of the regulations. So in different countries, so that and all matters. So what is foremost important here is the capabilities of a PCB manufacturer. So every manufacturer have different capabilities, and we should be very careful in selecting the PCB manufacturer. If the Gerber is given, so means Gerber means the PCB, the technology, what you call. So everything is there, like your drill files and layout and all other technology part. It put together is called Gerber. So that Gerber, we when we share to the PCB manufacturer, so their capabilities will comes into picture. So that is very important. Like in terms of minimum spacing, minimum line width, and minimum drill dia, and the what you call high density interconnect HDI PCBs, and micro vias. So that plays a very important role in selecting a PCB manufacturer.
Excellent, excellent. I know the design and under the design thing, it also, you have the thermal management also falls into that, which is a very, very important, I think, the factor in
Yes.
considering the printed circuit boards. What do you
Yes.
think on that? Yeah,
Yeah, thermal manufacturing is very
management.
important in PCB manufacturing facility. For example, if you are selecting what type of material, so that is very important. So to have that material selection, the designer
Hmm.
have to have the uh, thermal management in his design properly, because suppose if it is a multi-layer board, suppose it is having layer count is around 18 layers, 20 layers, like that. So thermal management is plays a very important. If that is not managed properly, see what happens, the board will get warpage. So nowadays PCB size is reducing. So, warpage of a PCB plays a very important role in the manufacturing, because the components nowadays are getting smaller and smaller.
Yeah.
So, like zero point 0.5 by 1 mm pad components, if we are assembling in our
Hmm.
SMT facility, then warpage is absolutely is not acceptable. So that is one thing about the uh, initial thermal management. And when you comes to the board reliability, so what happens if the right thermal gradient material is not used? So then what happens? All the reliability issues will come in the latent stages. So that has to be catered. So the selection of the material and the copper distribution along the material. So many aspects will come into picture that time.
So the manufacturability and the process control, it plays a vital role, and
Yes.
under the process control, the plating is one of the
Yes.
uh, very important process in
Yes.
the
Yes.
PCB manufacturing. What is your take on the plating as such?
So in PCB manufacturing, if we based on our experience, what we deal with our PCB manufacturers. So three important things comes into picture. One is the minimum drill dia, and the PTH, what we call electroless copper plating facilities, and copper plating. So these three things plays a very important role. So when you are talking about PCB plating, so I would like to come into that presentation part. So
Ah, yes,
I
there's a
have
slide there. Yeah.
dealt in detail about that based on our experience. So what is the PCB plating issues that we are experienced, so in the recent past. So that I would like to highlight. So you can go to second slide.
Yeah. What is specialized plating?
Yeah.
Yeah.
So in the specialized plating, so these are all the critical issues what we face. Like there are three important specialized platings we used to have in our garbers, like cap plating, via in pad plating, wrap plating. So what is cap plating? So it involves filling a wire with a conductive or non-conductive material and then plating over it to create a flat or a planar surface. So this is one important thing. So this is done in HDI, high density interconnect wire. This one is called micro wires. So less than zero point 0.5, 0.15 mm dias are called micro wires. So this cap plating, many PCB manufacturers having problems. And second is via in pad plating. So in this plating, wires are placed directly with the component pads. So allowing for a more compact design or improved electrical performance. So in order, see what happens if the, as I'm telling, as the days goes by, the size of the PCBs keep on reducing. So many challenges PCB manufacturer have to face. Like one of this is wire in pad. So right on the pad, the wires are placed. So with that, what happens? The two advantages are there. One is electrical performance will improve, and the size will get reduced. So this is very important, but it is not easy. It is not easy to achieve via in pad plating. So then the next is wrap plating. So wrap plating, what happens? The PTH is connected to the annular ring. So annular ring is a support in the outer circuit. So with the annular ring is connected to the PTH, so extra support we will get for the hole. So with that, what happens? It enhances the reliability of the wire structure. The wire reliability will get increased. So usually we face problems with these specialized plating, like especially in cap plating, wire in pad plating, and wrap plating. So I would like to highlight what are all the challenges we face and how to overcome the challenges. I would like to mention in these following slides. You can go to
Okay.
slide number 3.
Okay. Definition and purpose
So,
of each
what are the
plating.
different plating types, and what is the definition, what is the purpose, and what are the common applications here? So, this is required to understand the uh, uh, primary thing about this plating. Those who are interested, and what is the purpose of cap plating? As I told, the mechanical strength, electrical conductivity, and reliability. So these are the three important aspects in maintaining the quality of a electronic subassembly or main assembly when we are dealing with the RF and microwave products in the defense applications.
Mm.
So mechanical strength is very important because it has to withstand the harsh environments, and at the same time during that harsh environment that has to maintain the proper conductivity and reliability. So if you come to via in pad plating, uh, it reduces the routing complexity and improves thermal dissipation, because what happens if the size of the board is reduced, and the thermal dissipation, as you have discussed, so that will improve, and it enhances the signal integrity also. So this is primarily used in BGAs, fine pitch ICs, RF and micro PCBs. But here, the many challenges are there here also, that I will just discuss in detail in the subsequent slides. So next is wrap plating. So this will strengthen the via interconnect reliability. What happens usually, that is one term called a coefficient of thermal expansion. So this plays a very important role in the latent development, latent field applications. So there is a chance of because of that CTE, the wire get disconnected from the annular ring. So
Mm.
that could be avoided using wrap plating. But again, wrap plating is not an easy process. So it has to be done on the high density interconnect boards, and the plating as well as the outer plating, so that planarity has to be maintained. If that is not maintained, then you cannot able to solder on the pads. So those are the challenges, and it is a very complex process. So common applications like military, aerospace, automotive, and high reliability PCBs. So this type of these are the common applications. This
And these PCBs also need to withstand extreme temperatures or extreme
yes,
harsh environmental
yes,
conditions,
yes.
right?
Yes,
Okay.
of course. All defense and aerospace application PCBs needs to undergo this harsh environment. So that
Okay.
is, for example, if it is a aerospace grade, then it has to withstand the all airborne applications. Like, so whenever it has to go to 80,000 feet or naval applications under the sea or ground applications. So everywhere defense subsystems has to withstand that harsh environment.
Hmm.
So and that is one thing, and the main important part is reliability. So it has to withstand 10 years, 15 years, or up to 20 years of its service environment. So that has
Wow.
to be maintained.
I
So
mean, there are PCB manufacturers who can commit to this kind of reliability for so many number of years. Is that right?
yes, 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 yes.
Wow.
So that is a
Wow.
challenge. That is a challenge. So
Amazing.
uh, here, what I want to stress the point is uh, not only achieving this special plating requirements. So major is reliability. So we have to ensure the plating extra specialized plating what we are doing has that reliability requirements are fulfilled or not. So that is very important. So many tests we have to do
Hmm.
correspondingly. So if it is a defense application, then we have to ensure so all the requirements are fulfilled, and of course reliability is ensured in the defense applications.
Excellent. Excellent.
Okay, so next slide.
Choosing the right plating type for the
Yes.
PCB.
So for which application, so which plating is the choice and why that plating is required? So that we will just discuss. So for micro vias, best plating choice is cap plating. So what it does, it ensures reliability and conductivity as we discussed. In fine pitch BGA and RF circuits, so via in pad plating is um used especially. So what it does, it reduces routing complexity and improves thermal dissipation. And in military and aerospace, wrap plating is used. So because why this way I'm stressing the point is, so many PCB manufacturers nowadays are facing difficulties in achieving this uh, plating requirements, because as an example, so we are doing one PCB for Israeli aerospace products. So there is some specialized plating requirements is there in the Gerber, but many PCB manufacturers they are continuously rejecting 3 times, 4 times continuously. They are rejecting and relaunching the boards. So this we are worried actually. This we are worried with PCB present scenario. But what happens? It increases the lead times and all the reliability issues. So that is a very important point. Okay. So next
Okay.
slide.
Next slide. Yeah.
So you can go to slide number 6. If you see yield
Yield
and
and
defects rate by plating type. So here, if we see the overall yield trend, so cap plating having 85% of the this one yield, and via in pad is having about 90%, and wrap plating is very difficult. So that is around 80% of the global average yield you can achieve. So what are the common defects? It is also highlighted here. In cap plating, void is the major issue, and uneven copper deposition is one issue, and planarity issues, because the cap means it has to be in the it should be absolutely plain. There should not be any bump, or there should not be any dimple in the after cap plating. That is one thing. And the voiding. So the plating should be continuous. So even if it is a micro via and blind via, so the plating should be continuous all over the pads and on the barrel. So plating should be uniform. So uneven copper deposition will create a problem. So these are all the issues that reduces the yield in cap plating. So this can create open circuits, poor solderability, and via failures. So as we discussed, so we cannot repeatedly rework these pads. So
Okay.
reverse simulation test we have to do. So they will fail during reverse simulation test. So these are all the issues. So similarly in via in pad plating, solder wicking, because what happens, yeah, since it has a extra copper deposition on the pad, so what happens, the solder will wick, so it will take extra solder paste. So that will if you see the solder paste selection, we cannot select onto the single pad, so it has to be distributed all over the board. So, but wherever the wire pad plating is there, so there we pose uh, issues due to the variation in solder paste. So maybe extra solder paste may be required, and some trade-offs we may have to do while selecting the amount of solder paste. So those things are there. So usually it will lead to BGA soldering failures. So BGA is very complex device to manufacture. So once the BGA is assembled, so it is very difficult to identify the issue. So in between, so one via in pad is having problem is, so whole BGA is in trouble. So that is one thing. And wrap plating, so what are the problems we face is insufficient wrap coverage. So wrap plating, as I told, it is plated to have the extra protection for the PTH. So that will lead to risk of delamination and conductivity failures. So what happens with these defects, based on our experience, PCB rejection rates due to plating defects is around 15 to 20%. So
Wow.
we have around uh, five PCB manufacturers. So based on this data is taken. So usually they will face problems, whatever the type of PCB, it is 15 to 20%. So again, this rework increase the lead time by 5 to 15 days. So this is the average delay. So somehow they will fulfill the requirement, but again there is a delay. So this delay is a concern. So manufacturing cost impact for defective board is around $2 to $8. So this is also,
Wow.
so again the cost will increase.
So this is the cost after you have populated the PCB.
No, no. This is the
No.
cost. This is the bare
Okay.
board cost.
Bare
Bare
board
board
cost.
cost. Bare
Okay.
board.
Wow.
So we may face problem at after assembly also.
Hmm.
So in field failures, so we may have to take extra boards,
Yeah.
and what happens if we may have to pay extra cost also, because it varies from manufacturer to manufacturer. Cost varies. So that cost, we have to buy, or customer have to buy. So there is some impact. Cost impact is there because of that defective boards. But for high reliability industries, we cannot live with this.
Take chances.
Tech.
Yeah. Yeah.
So we
Yeah.
cannot take chances. So the overall board cost of the board is very high.
So it's very interesting to see all these challenges, and you are pointing it out so very well. I think the PCB suppliers of yours must be lucky that you are able to give such solid feedback to them for improvisation. So okay, I just wanted to make a comment in between, so you can continue.
Okay. So next slide. So this is one point what I want to make is how they are interrelated, how the cap plating and via plating put together. So it both involve, both makes a via structure. But cap plating is specific to micro vias, while via in pad plating is for reducing PCB space and improving component connections. So this is what I want to highlight is how they are related to each other. So the point is they are interrelated. They are interrelated. They are not separate. So one PCB may have cap plating and via plating everywhere, and they are interrelated, and they are the effect is a overall all put together. So one board only having cap plating or via in cap plating, so the issue of the reliability is a overall impact put together. So you can go to next slide. So this is slide number 8. So this is what we highlight is manufacturing process comparison between three different plating types with respect to process step. So if you take the cap plating, you will just understand the process here. So first is laser drill microwave is the first process. Then electroless copper seed layer is the second process. Then electric copper deposition is the third process, and planarization is the fourth process. So why this is important is the complexity. The
Hmm.
first of all is laser drill. Microwave is the first complexity. Then once the laser drill is done, because this is the microwave. Microwave means it is around 0.15 diameter hole. So we have to plate on the blind wire. This is on the blind wire. So
Hmm.
if the drilling is done on the blind wire to such a small hole, so we have to deposit copper through electroless means, because you cannot. Once the drilling is done, so there are dust around the hole is there. It is called smearing. Smearing effect will be there because it is a high speed drilling. So we have to remove the smear around, and you have to build copper on the layer. So this is very challenging. And electrolyte copper deposition. So
Hmm.
once the copper is built, electroless means, so we have to plate copper, extra copper. So the fourth process is planarization. We have to make that via flat. There should be any bump or any dimple kind of thing.
Yeah.
So this is a very critical process, and many manufacturers will fail in this process. So via in pad, if you see, first we have to drill on the component pad itself. So this is one more problem. So again, fill via with the conductive or non-conductive epoxy. So in this process, what they are doing is they are filling with conductive or non-conductive epoxy, because so component is going to mount on that pad.
Hmm.
Component itself is going to mount on that pad, because it should be absolutely flat. If uh, any variation is there on the pad, your component will not sit on the pad. So that is a
Right.
very challenging. And once the component is assembled, if it is a BTC component, uh, BTC means bottom termination component. So if that is to be inspected in X-ray only, you cannot see it through the naked eyes. So during X-ray inspection, we face a lot of difficulties because of this via in plat plating. So then plate via with copper. So then planarize the surface. So this is the process in via in pad. So the wrap plating, the process is drill the via, then electroplate the barrel, then extend copper plating into another ring. So this is the most complex process any PCB manufacturer will have. So this slides will clearly understand. So what is the plating type? So how the
Yes.
process is done? So that kind of thing.
Okay.
So you
You
can go
want
to next.
next slide? Yeah. This is the
So
same thing. Plating
yeah, yeah.
challenges.
So
Yeah.
what are the challenges I explained? So same
Yeah.
thing.
So next slide, please. Cost consideration, HDI
Yes.
PCBs
So
with the
the HDI layers are there. But more layers means the higher cost. See,
yes.
the cost of the PCB is increased because of different processes. Suppose if it is stacked versus staggered vias are stacked. Either stacked means so it is in the same line. So suppose if it is a multi-layer PCB, it is stacked on the same orientation. If it is staggered at different orientations, so it requires more process steps. So it is a more costly process. So then high frequency laminates are costly. So this slide indicates the cost impact is there. If you are going to manufacture this microwave plating, there are many cost impact is there. So the cost of the PCBs becomes very high. So many manufacturers will avoid in this process. They will not invest because of these complexities, and they don't want to take risk. So not many manufacturers will take this risk and do man. But the, there is the requirement. So that this plating has to be done. So in every Gerber, what we receive from the manufacturer, from our customer, will have this micro vias. They have to do it, and not many manufacturers will do that. So we are facing problem.
So one question I have received. So
Yeah.
they are asking like what kind of um, approvals are needed for a defense application for the PCB.
There are many uh, approvals are required. Means main is mill approval.
Yes.
Mill
Okay.
approval.
Mill standards.
Mill
Okay.
PRF 31032
Okay.
the standard is there. So any PCB manufacturer will have to undergo that approval. Okay. So it is done by American military agency, approve as per their this one, and we have to submit the coupons.
Hmm.
So it is a process related approval is there, as well as material approvals, and in every aspect they will just verify, and they will approve as per PRF 31032 requirement. So your PCB becomes mill grade PCB. So that is very important. So nowadays all defense applications will have mill grade PCB approval. That is the first and foremost. So that is about the universal defense applications. When you come to India, there are many agencies are there. It is called JSS application, Joint Service Specification approvals are there, and automotive approvals are there. So the specific to your requirement, any approval,
Applications. Yeah.
yes, that
Okay.
has to be done.
Very well, Mr. Gurudatta. We have crossed our almost the time. So I think it was very educative, very informative session. You gave us about the challenges that are being faced in the PCB manufacturing for very advanced technologies like defense, aerospace, kind of boards. So, any message you want to give it to our audience? Any brief message, 1 or 2 minutes?
Yes. So the PCB manufacturer have to, any PCB designer, Gerber designer, have to understand the PCB manufacturing facility constraints. Then accordingly, they have to design their PCBs. They have to understand the process, what is their capabilities, what they can able to manufacture. So it is a trade-off between the designer and the manufacturer. So manufacturer, they are having their own problems in the process, in the selection of materials, everything. So that has to be aligned in designer has to align those requirement into his design, and it is a mutually agreeable situation. So that has to be arrived, and definitely there are future is there in PCB manufacturing if you have facilities like cap plating or HDA interconnect. So that kind of facility, definitely there is a big future. So anybody, if you want to invest in those processes, definitely there is a lot of scope is there.
There's a market.
Particularly for the PCB
Manufacturing.
defense application. Yes.
Excellent, Mr. Gurudatta. Thank you so very much again for your valuable time, because
Thank you.
I know it's a Friday evening and weekend begins and everybody has their plans, but you have given your valuable 1 hour with for Global Electronics. And also thank all the audience, whoever are able to watch. Is today is a little challenging also to watch because it's Valentine's Day. People have plans, people have different things to do, wherever whichever part of the world you are watching this. So but I thank you. You can always watch it because it's available on our YouTube channel. And definitely, if you want to be part of a Global Electronics talk show in the future, you are more than welcome to write to us, and with the topic that you are interested in talking, so we will be happy to host you. Global Electronics main point is to promote electronics manufacturing challenges, promote electronics manufacturing, and also bring in the experts so that they can share their wealth of knowledge with our audience, with our community people. It's basically serving the electronics community. With that said, your host Rajiv Kulkarni will sign off today's episode. Next week we will have a premiere which will be relayed because I'm traveling next week, so I won't be able to host live show, but there will be a premiere of the previous one of the shows which we will be relaying. But the following week we will come back with another guest, another topic. Till then, stay healthy and be happy always. God bless. Thank you very much.
Thank you, sir.
Thank you.